today we will look at derivatives and actually an application of a derivative looking at the instantaneous and average velocity. So let's get started. Average rate of anything is the change of the y value over the change of the x value. If we take an x1 and x2, it's going to be f of x2 minus f of x1 over x2 minus x1, which is pretty much the slope of the secant line over there. Now, if I take that change from x1 to x2, very small, and call that delta x, and I make that delta x very, very small so that it is almost 0. So if I take the limit of that and make this very, very small from x1 to x2, that slope of the secant line is going to be the instantaneous rate, not the average rate. So, we are going to look at a physics example where we are giving s of t, the position function. We are going to show the derivative of s of t is going to give me the velocity, and the derivative of velocity is going to give me the acceleration, or the second derivative of the position function will give me the acceleration. And then the change represents the average velocity over a time, and the ds dt will represent instantaneous velocity at a certain time. So let's go and look at that. Okay. I'm trying to adjust the volume so that it's not too much. Here we go. Alright. Let's say I'm given an s, t cubed minus 6t squared plus 9t, and the first question was the instantaneous velocity after 2 seconds. Well, remember how we used to do that? We are going to try to take the values and take the change from a point. So, for example, I'm going 2.1 to the right of 2, and then 2.01 to the right of 2, 2.01 to the right of 2, and then same thing with the left. And I will calculate these values, s of L1, and put it in L2, and then apply the secant line slope formula in L3. So let's do all that. So I go to stat edit. I enter these values 2.1, 2.01, and these are like x2 values. I'm going to go and calculate the x2 values, so it's like s of 2. So how do I do that? I need to put that formula in, so push enter. And I'm going to take the L1 cube minus 6L1 squared plus 9L1. That's going to give me these values, and it's consistent. Now in L3, I'm going to put the slope, f of t2 minus f of t1 over t2 minus t1. Alright, so let's look at that. F of 2, so that is the t1, is going to be 2 cubed minus 6, 2 squared plus 9 times 2. And that actually gives me the number 2, so I can put that in there. So I'm going to enter. L3 is going to be f of t2, which is L2 in this case. And I'll put the left parentheses. Oops, no, that's not what I meant. Just that. L2 minus L1, and I told you that f of f of 2 is going to be 2, so I'm going to just say 2 divided by, and that's going to be the difference between this value, this value, T2 minus 2. So T2, I just actually put it at L1, so I'm going to put L1 minus 2. So I should be getting these values in here when I push enter. Yeah, it looks like it. So it looks like I'm approaching -3. So the -3 is my instantaneous velocity at 2. Very good. That was the answer to first question. Now, I'm going to use the derivative method to find it. You can go and calculate this by hand, the derivative of s, and this gives me 3t squared minus 12t plus 9. You can do it that way. Or you can go and use this dy dx feature. So I'm going to do both. I'm going to enter this function x cubed minus 6x squared plus 9x. Let's say I'm looking for the instantaneous velocity, which is the first derivative, at 2. I can go to calculate right here. And I can go to dy dx, which is number 6. And say, okay, well, I'm looking for dy dx. Oh, it's doing all of them. So here's the function, and I want to enter. Oh, it is okay. So let's clean this up first. I want to go and format this because I don't want to see the grids. All right, so I'm going to put grid off, and I want to do everything in rectangular coordinates. So I went and did that, and let's get out. All right, now I'm going to try it one more time. And I will take out the derivative and acceleration formulas out. The way I do it, I go to the equal sign and push enter, and you will see it's going to turn white. That means I'm not going to look at it. So all I'm looking at is s of t. So I'm going to go and pick calculate, and I want to take the derivative, dy dx. Here we go. And I'm not going to see the velocity and acceleration. So let's go and get the dy dx. Let's say I'm doing 2. Guess what it did? It went not only to the point, it also went and calculated the value of the derivative. The second way of doing this with the graph is you can go and enter the velocity function in there by taking the derivative by hand and make this inactive by going and pushing enter. And now remember, I'm looking at the value of the velocity at 2. So instead of taking the derivative, you can actually go to second calculate. This time I'm looking for the value of velocity. Push enter. Now I'm going to see only the velocity at 2. Guess what? It just went there and it showed me where it is, and the value is -3. So you can do it either way, by using the derivative or by taking the derivative using the value function. Now if you want to see these things, you can go and make that active by pushing enter, and you can modify your window to see a nice graph. Let's try that. I will go from 0 by pushing window. I'm going to go from 0 to 5. And I'll use steps of 0.1. And I'll go from -1 to 7. Steps of 0.1 again. And when you graph, you're going to see a nice graph. And then you can take the instantaneous velocity by going second calculate, just like I did before, and use that to get a nice graph. Here we go. It shows it to you nice and pretty, and it tells you where it is. Let's analyze this a little bit. If I'm looking at the average velocity, what do I need to do? S of 3 minus S of 2 over 3 minus 2. You just plug in the values. You can get these things from the value function. So the average velocity is negative 2 instead of negative 3. All right, well, let's look at it a little bit closer. Okay, the particle moves in a positive direction when your velocity is positive. Okay, you can actually look at this 3t squared thing where, let's look at the velocity function. This one is, I'll make it active, and I'll look at both of them. When my velocity is positive, here and here, it's going to move in the positive direction when the velocity is positive. If I want to find out, instead of doing this by factoring, I can go to that value and try to find the x-intercept. One way to do that, you can go to calculate again. And I'm looking for the 0 of that function, right? So, not that one, but the velocity. So let's go to the velocity function by jumping to the velocity. Here it is. Left bound, let's say I am on the positive side, say enter. Right bound, just go to the right of it, say enter. Yes, here we go. It went and found x equals 1, which is t equals 1, which makes this positive. Remember? To find this value, you do the same kind of thing. You can go to second calculate and then get the 0 of that function. I am on the wrong graph, so let's do down and let's go in that vicinity. I'm going to the right. Here it is. And then left bound. My left bound is going to be around here. Right bound. Here it is. Yes. And here it is. It found at x equals 3, which is t equals 3 here. Okay. This inequality is true when both factors are positive or both factors are negative. Okay. So here we go. So this is going to be true when they're both positive or they're both negative. Alright, that the particle moves in the positive direction in the time interval less than 1 and bigger than 3. Here and here. The particle is at rest when t equals 1 or t equals 3. Right? T equals 1 or t equals 3. That means there is no velocity. It moves backwards in the negative direction when t is between 1 to 3, when it's from 1 to 3, when the velocity is negative. Alright? So you can look at how the particle moves. At 0, I go and calculate s of 0. At 1, s of 1. At 3, s of 3, and so forth. It actually does this. If I'm looking for the path, the total path, and all what happens in the first 5 seconds, like the question is asking, I have to take the absolute values, go and calculate f of 1 and f of 0, and subtract and give a positive number. Same thing 1 to 3, because that's where the velocity is crossing the axis. And then after 3 to 5, around here. So I have 4 meters, 4, and 20, so it actually traveled a total of 28 meters when you look at it. If I'm looking at the acceleration, I know there's the derivative of my velocity or second derivative of s of t. You can go and take that, and let's look at that. and I can take that and put those S of t right here, V of t, and A of t all in the same graph if I need to. If I want to calculate, for example, acceleration at 4 seconds, all you have to do is just take the second derivative and plug that in. Or you can take the value in here or the derivative of that, just like I did before. So if I'm looking at the picture, I can see that. Let's graph that. You can change your window a little bit by taking like y min of negative 12. So I will do that. Y min is negative 12. That's a little better. You can see it. Alright. The particle speeds up when velocity is positive and increasing, and when the velocity is negative and decreasing. Either V and A are both negative or V and A are both positive. Here's your V. Positive. This is negative. No. It is positive here and here. Look at that. So in other words, the particle speeds up when the velocity and acceleration have the same sign. Here, this and this. Alright? Or when between 1 and 2, remember how it was between 1 and 2? It is both negative, negative, negative. Do you see that? So you can do all sorts of analysis by looking at things. The particle slows down when V and A have opposite signs. And you can look at that. You can find, using this calculate button, you can try all sorts of different things and use these features. Second, calculate. Value, it will calculate the value at a point. 0, where it cuts the x-axis. And dy dx, where you can just even not take the derivative and let the calculator take the derivative and tell you the value. So this is a very, very useful feature when you put it as a function within the equation editor and use the calculate button to calculate all sorts of exciting values.